Now it brings us to example D. Example C was depreciation. Example D rightfully will be appreciation. So we are expecting this. Appreciation means it is growing. So we are expecting this to be a growth function. As a growth function, let's go ahead and identify our details. We know that it was sold. Baseball card is originally sold for $2. So our initial value will be $2. And we know it's appreciating 8% each year. So it's increasing in value 8% each year. So our B value is going to be the 1 plus the 8%. Rewriting that as a decimal, so 1 plus 0.08, which gives us 1.08, which we can see is greater than 1, so it is the growth that we expected. Okay. We know we're talking about after each year. We want to know the value of the card after 10 years. So our variables, we can let t equal time. And I'm going to say in years, so we know what the unit is. And we'll let c equal the value of the baseball card. Okay. So to write our function, we know that c of t is going to equal our initial value of 2 times our exponentiation 1.08 to our variable t. We're asked to find it after 10 years, so c of 10 will equal 2 times 1.08 to the 10th power. And using a calculator, it's not going to be as big as we thought, but again, it's growing from $2, so it's a significant amount of growth here. Just 8% is going to give us $4.32. It is more than doubled in those 10 years. So that's a pretty good return on someone's investment. So, answering the context, the value of the baseball card will be $4.32 after 10 years. That, ladies and gentlemen, is an example of depreciation. Or sorry, appreciation. Thank you.